Hello, this is Mr. Stansbury. I'm going to take you through the notes on solving other equations using technology. Okay? At the end of this, you should be able to say, I can use technology to solve various unfamiliar functions. Okay, so really just have these two examples for us. But what we're going to do is we're going to use technology to solve these things here. So the solutions, it's important to know that solutions are where these two things are going to be equal, right? It's like what values of x can we put in here so that this equation here will be true. So the way we want to find that out, using technology anyway, is we do the y equals. Okay, this y equals, we're going to actually graph these things. We're going to be able to see the graphs. So we're going to push y equals, and then in one of these, like say in the y1, we're going to put what's on the left side. So we got 2 over x, and on the other side, we got 3x cubed minus 1. Okay, so we're going to put those two equations in, and then what should hopefully work for what we're doing now is we want to do zoom, and we want to do 6, which is zoom standard. Okay, once you do zoom standard once, every other time that you push the buttons on this, it should, like when you go to graph after this, it should end up giving you the same windows until you change it. Okay, so here's what we're looking for. We're looking for the red, where the red and the blue intersect. So there's 1, 2 spots here where they intersect. So we want to find both of those points there. Okay. So what we have to do is we're going to go into the graph part, which is all these buttons up here, and we're going to calculate. We want to calculate where the intersection is. So since the calculator is up above in the blue, we have to do second, and then push the trace button, which will give us calculate. And it gives us these options. We want number 5. It's where we want to know where the graphs intersect each other. So we push 5. And then now it's going to do this. It's going to ask you some questions. It says first curve. And you're like, so basically you could have a whole bunch of different graphs on here because this y equals window here, you could have a whole bunch of different equations in here. They want to know which two equations or which two graphs you want to find the intersection of. Okay, so on this graph here, we are going to look for the intersection. It says again, first curve. So right now you should see this little plus cursor in here and it's not there. So what we're going to do is we're going to push the button until we find it, and there it is. So first curve is the blue. Is this one of the two graphs that you want to find the intersection of? Yes, that is. So I'm going to push enter, and then you'll notice this cursor is going to jump down to the other red, sorry, the other graph, the other red graph here. So is this the second curve? Is this the other one that we want to find the intersection of the two graphs? Yes. And then it's going to ask you a question. Do you want us to guess? It's like, sure, go ahead, guess. But just go ahead and push enter. And then what it's going to do is it's going to actually calculate what the intersection point is right there. Okay, so if we're looking for the solutions, remember that's always the x value. We don't even really care about the y value. We really just are concerned about the x value. So that's going to be negative 0.796, we'll call it. So one solution is x equals negative 0.796. Okay, and then we got to go back in and we got to find this intersection over here too. So we're going to do the same thing. Second, calculate. 5 is the intersect, so we can just go, you can arrow down to 5 or just push 5, push enter. And then now, is this the first curve? Here's what you want to do. We want to get this cursor closer to this intersection point. Otherwise, it's just going to find this intersection again. So I'm going to push to the right until it gets over close. I usually don't like to have it right on top of, because then I can't see it switch graphs. So there's the first curve. I'm going to push enter. It's going to jump to the other red curve here, and it's kind of nice with this color one because it actually changes colors as well. Is this the second curve? Yep, that's the second graph. You want us to guess? Sure. And we push that, and we get the intersection is at 1. So we get negative 0.0796 or 1. Those are the two numbers that are going to make the two values of x that are going to make this this equation here work. Okay? All right, let's take a quick comedy break here before we do B. let's take a look at B here. Okay, so we'll do the same thing here. We're going to go into the y equals. We don't want these old ones anymore, so we'll clear both of those out. So you just go to those spots and push clear. All right, and so the first one we're going to want to do 3 to the x power. So 3 raised to the, and then here's again our xt, theta, and n. That's our variable. So 3 to the x. That's the first one we want. And then the second one, we've got negative, not subtract, but negative x squared. Let's see, plus 5. Okay. So we have these two in there, and then again, we already, on the earlier one, we already did zoom standard, so we should be able to just push graph, and hopefully these two graphs will end up being their intersections will be within this window. Let's find out. We got to see where the red one is. Okay, there it goes. Oh, good. Look, both of the intersections show up in the window. So we're going to just do the same thing as we did before. Second trace, which is calculate, and we are going to look for the intersection. Okay, first curve. This is kind of right in between those two, so I'm going to move it over here to the left a little bit so I know I'm getting this first intersection. Enter for the first curve, enter for the red one, give it a guess, sure, and it's going to calculate our x value, negative 2.22 it looks like. Okay, and then let's find, and there's going to be a second one in there, right? So then let's find the other one, second trace, which is calculate, intersection, and now we got to move this cursor over closer to the other intersection point. As long as it's closer to this one than it is that one, it will find the new one. So we'll push enter for the second one, enter for the to give it a guess, and there's the other one, 1.17. And those are our two solutions. So if we were to plug in either of those two numbers, 1.13 to the 1.17 should equal negative 1.17 squared plus 5. So that those should be equal, or since we rounded them, it should be very close to equal. Okay? All right, that's all there is for solving other equations using technology. If you have any further questions, please feel free to ask in class. Thanks.